So this is a quick little video to show you how to use the cloud-based chart that you were asking about. So this is what you should have, and if not, I think I will scan this and attach it in the email that I'm sending this to you so that you can use it. But this is what you use when you're trying to determine the bottom of the cloud. The two things you need in order to do this is you need to know the surface air temperature and the surface dew point. And here you can see dry bulb is also called the air temperature, and then the dew point. And we would be using a sling psychrometer to help us gather this information. Once we have them, so let's say the air temperature is 20 degrees Celsius, the dry bulb, or air temperature, and the surface dew point was 12. So what you would do is you are going to follow the solid line up, and so I use some sort of straight edge. So here I have a little sticky note. You can use a piece of paper, whatever you'd like, that I'm going to use to follow along with the solid line and make sure it stays right on that line for you. So here's my line for 20, and so now I go down to 12, and here's my 12. I'm not going to follow the solid line up, because if I do, I can see that it'll be parallel. I want to follow the dotted line up so that they will intersect, and they do way up here. And if you can see, I'll draw right on here for you. You can see that they're intersecting at an altitude of 1.0. So the cloud base for this is 1.0 kilometers above the surface. That's the base of a cloud when the surface air temperature is 20 and the dew point is 12. So now the other part is so what happens to the cloud base if my dew point gets farther and farther away from the dry bulb? So let's see what would happen. So here it was at 12, but let's say it was 6. So if I follow this up, the cloud is now getting higher in the sky, which means the air is getting drier and drier. As the air temperature and dew point get farther apart, the air is drier. Now, on the other side, what if the dew point was really close to the air temperature? Let's say it was 18. If I follow this up, you can see that the cloud base would be about 1.3. So 1.3 kilometers above the surface. You can see that it would be a lot wetter in the atmosphere. The clouds are a lot closer to the ground. Therefore, probably your chances for precipitation would go up. So this is your cloud-based chart, and that's how you would use it to help you determine the bottom of the cloud. You're going to complete a lab that will help you practice using this. Please email me if you have any other questions.